Okay, we'll go ahead and get started. Welcome to the presentation today. It's Breaking into the Black Box, Forensic Analysis of AI Systems. A little bit about myself. So I've been doing corporate investigations on the digital forensic side for a little over 20 years now. Not on the criminal side, but on civil. So large-scale corporate litigation, consumer litigation, government inquiries. And over the 20 years, there's been a big shift in terms of the kinds of technology that have been analyzed and examined forensically. Obviously, over the last 5 years, AI is coming to the forefront. And what we've seen over the last 3 years is that most cases we're examining now have some element of AI analysis, whether that be actually examining AI systems, which we'll talk about here, or examining evidence for having been altered or created by AI. So deep fakes, but even Zoom enhanced resolution issues and various software artifacts that influence digital evidence. Here, though, we're going to be talking about AI systems as evidence. So examining those systems that may have malfunctioned, were designed improperly, were used maliciously, or otherwise contributed to some type of litigation or regulatory violation. So the case we're going to look at today is a fabricated one. It's rather trivial, but we have a chatbot, and this is rather common in litigation right now. We have a chatbot. It's not only racially discriminating by proxy of zip code, but it's also leaking other conversations. It's based on a foundation model, improperly designed, improperly trained, and doesn't have the proper context window. So one user will be chatting, and it dumps all the PII, personally identifiable information, from another user to that user. So we're going to talk about it. But when we investigate, we're looking at a few things. Did it actually happen? Do we have evidence in the form of logs, the ability to recreate it, or some other type of third-party evidence? How much did it happen? So looking at the scope of the violations, did it happen repeatedly? Did it happen 2 times, 5 times, 4,000? This impacts damages and other factors in litigation. Is it still happening? Has it been remediated, meaning has it been fixed and corrected, or is it still occurring? And then finally, what was the root cause? Was it intentional, was it accidental, or otherwise? So really quickly, looking at digital forensics, we have a pretty basic model. When you're doing software development or maintaining your own product, and there's something that's going wrong, you're debugging, or you're testing, or you're auditing, you really focus on this side of it. You might do a dump from a database, you might do a source code examination, and then you do an analysis and write some type of report. For forensics, to meet certain evidentiary standards, we need to add a few layers to this. We're going to be preserving the data in a defensible way, meaning we're going to lock it down, be able to identify everyone who's touched the evidence, and be able to verify that throughout that we're working with original and valid evidence. We then go through a fairly painstaking process around collection and then perform fairly standard analysis that you would in those other contexts, but then layer in a much deeper type of reporting. So the principles don't change when we're looking at this general digital forensics versus other things. And one example is mobile devices. Most cases now also include some evidence from devices. And what we'll do is we'll use forensic software. It'll automatically collect data from it. It'll verify it. We then do analysis, whether it's on WhatsApp messages or web browsing history, and then report on it. When we look at AI systems, though, it's very different. Just how they operate, the scale of the systems, and the way they work. For one, it's a black box in many types of AI systems. Specifically around LLMs, we're seeing that there just isn't much of an ability to have explainability. Even the systems that are so-called explainable AI don't meet those standards that we're used to for deterministic traditional software systems. So you have a black box problem. You have a scale problem. Some of these systems are in the petabytes of data. This is not something you can then load onto a hard drive, run a hashing algorithm against, and then perform substantive analysis. Instead, you need to have very targeted methods of, say, sampling the data or looking at behavior, or not even examining the data itself, but looking at how the system was designed. The non-deterministic nature of it means you can't recreate issues as easily. There also is this factor of shared accountability. We're building AI using just layers and layers of open source models, proprietary models, foundation models, different techniques, different developers. So pointing the finger at one culprit is difficult, and it actually is contributing to new theories in the law around vendor, or what's called an agent, liability. If I get an HR software from a third party who uses AI, that software vendor may be responsible, or I might be responsible because I didn't set it up right. The evidence is evolving. Because of the scale, a lot of it is not retained. It's getting flushed at fairly regular intervals. And lastly, legal gaps. The law is usually 4 or 5 years behind any kind of technology anyway, but this is developing so rapidly. There are huge gaps around even, can you rely on AI to summarize evidence, or what constitutes a deep fake? The threats around AI are significant in the legal space. One, bias and discrimination. This was a major area about 8, 9 years ago, all the way up till maybe 2 years ago. And that's looking for systems that are biased, perhaps based on their training data or how they're implemented. Recently, though, we're seeing much more around data privacy and IP theft, where for data privacy, we have leakage of PII, the use of PII in training. So your own identity, your own name, your address, other information like that being collected and integrated and potentially leaked through the AI system. And the same type of theory around intellectual property, where you might have book authors or journalists citing that they have the rights over certain information that they created. However, because of the transformative nature of AI, there are arguments what's fair use and what's actually copyrightable. These other theories around product liability, these systems can cause harm, whether it be in the form of autonomous vehicles or even a simple chatbot. Fraud and deception, this is a growing area. It's really easy now to run large-scale fraud networks in all manners of operation. Regulatory non-compliance, this one is evolving as well. We're seeing a lot of state laws picking up the mantle from the lack of US federal regulation and comprehensive views on how we are to regulate AI. So you have state laws such as the California Consumer Privacy Act, you have GDPR in the EU, and various other state laws in Colorado, Illinois, Texas, it goes on and on. Security vulnerabilities, there are ways to circumvent AI systems that are fairly standard, that are not checked for. Even cyber insurance policies don't cover AI as prominently because of these vulnerabilities. And lastly, lack of transparency. The unexplainable decisions and it going off the rails from its intended use, very similar to product liability, but makes it difficult to ensure that your product, your AI product, will behave based on how you tested it. Okay. So we're going to talk about this basic bot. We're calling it Refund Bot. It's a very simple GPT 4.0 mini model trained to perform automatic refunds for customers. The idea is they chat with it, they explain what the issue is, it has certain thresholds, it'll ask for their information, and it'll make a decision about whether a refund can be issued immediately or whether additional information is needed. So the standard way this works is you log into this bot, gives all this basic intro information, it asks for your name and email address. The user enters this, Sarah Miller. Thank you, Sarah. Can I get your order number and the product that's supplied? Thank you. Can you let me know the reason for the return? Right earbud has no sound. Could you provide me with your zip code? There it is. And decision approved. So this chatbot just asks some pretty basic questions. Again, it's based on a foundation model. It feeds into the database for this company, for TechMart, and provides this, and we'll update the database based on this interaction. However, there's a problem with it. Going through the same set of steps, here we see, okay, same information, name, email, order, same exact product. Could you let me know the reason for the return? It stopped working, right earbud's a problem, provide me with your zip code. And once the bot goes through this step, it asks for a government-issued ID number, a photo of the product showing the issue, and a handwritten note with today's date. So the only difference between these two scenarios is the zip code. So something in the system is different. And it's a pretty big issue because US courts have established that zip code serves as a proxy for potential racial discrimination. So this not only violates several federal laws around the FTC and Equal Credit Opportunity Act, but it could also apply to state laws. So this could be a pretty major one based on the volume and whether this can be established. So the questions are, when you go into a forensic examination, you're looking to understand, is this a pattern or is this a coincidence? Can we prove that the zip code is the cause for the issue? And ultimately, what is the root cause? Was it designed this way? So were there explicit instructions to design this system to require certain information based on zip code? Or is this one of those unknown, unexplainable issues that goes back to the foundation model? If so, was it tested for? Was it examined? How thoroughly was this bot ultimately tested for? Okay, here's the problem with AI. With traditional software, you can go to the source code. It's deterministic. You could say there are rules, there are thresholds. We could enter inputs, get the same output every time. With AI systems, we can't. It's not deterministic. Based on how the model was trained, it could behave differently, and the number of potential issues with it are too much to explore, again, deterministically. So we can look in a number of places. We can look at the source code. So how was this trained? How was it developed? We could look at the database and logs. Is there a pattern of this occurring for certain zip codes? Are there logs that indicate why it made this decision? So certain explainable systems will give you that information. We could run tests on the live system, so we could actually load the system, run it through a number of times, give it different zip codes, and isolate that as a variable. We could also isolate other variables, so we can run black box tests. We can look at the training data. Perhaps the training data was biased itself. There were certain training data records that showed a higher rate of fraud associated with certain zip codes. That might be one reason. We could look at system logs. Maybe there were errors, maybe the API timed out, and that's the default response. Again, we can keep going down this line. My favorite area to look, though, is always communications and documentation. Communication across developers. So if you are a developer of AI systems, be careful around your communications. Right? If you sense there's a potential issue, bring it to legal. Don't put it in Slack channels. That's the first place I'm going. Because if I find evidence that a developer said this thing's racially biased and it didn't go anywhere, that's my starting point and potentially this smoking gun for the examination. Next is documentation. Whether you actually use an AI bill of materials and develop the proper full stack of documentation around your testing, configuration, that is still where I'm going to look. And if you have partial documentation, we'll look there and start to examine gaps to say, this wasn't tested, there isn't documentation of it. Let's start looking at other areas where this may have fallen short in its design. Yeah, so the question comes down to, could you prove what we just saw in court? What evidence would you need? This is another challenge for AI examination. This evidence needs to be presented to a non-technical audience in trying to explain how a foundation model relates to some kind of prompt engineering for this, and the importance of certain tests and other controls and safeguards put in place is difficult. So what evidence would you need? That also goes back to communications. If I find documentation that a developer spotted the issue, that's a lot easier to share and use as convincing evidence than statistical analysis like Shapley or Lime on training data. So the first step is hashing at the data source. And when we hash data at the source, what we're talking about is we're going to look at the live system and lock it down. So if we can make sure that this evidence is not being altered in real time by taking it off the network, taking it offline, or collecting it first, we're going to do that. So we're going to collect the data. We're going to run SHA-256 for this. This brings me to the other challenge around scale. If you are examining large volumes of training data, talking 500 plus terabytes into the petabytes, you can't just collect it, and then especially not SHA-256 it, because it will take weeks. The computing power required to do this, or the number of people with each holding 10 terabyte drives, will take a lot of resources. So you have to make a decision early on around what are you going to collect, how much of it, and what your basic training collection process will be, but also model collection. Do you need the model? Do you need the training data? And if so, what are you going to do with it? Here, we're lucky this is, again, a trivial example, just measured in the kilobytes. We have a database, and we have a simple Python script. So it's straightforward. We're going to collect it, SHA-256 it. This serves as the fingerprint for it. So if anything changes between this point in time and later, it'll show up as a different hash value, which means it's been altered, which means it doesn't have the same integrity, which causes concern and issues, blah, blah, blah. But basically, it helps validate that this is forensically sound. So you've collected it, and now we're going to get some of the additional information. We're going to get logs. We're going to preserve additional source code. We're going to collect communications from developers, whether that be Slack channels, might be their mobile devices. It's going to be emails, especially around executives and anyone involved in setting up audit protocols and compliance. Then, after we do this process around extracting logs, we're going to run this script. Again, SHA-256 it. We see there have only been 100 sessions. So only 100 users have used this refund bot. There have been 1,080 messages and 1,000 decisions. This is our baseline for the examination. Again, because it's so small, we're going to do a substantive examination of everything. And then once we're done with that whole process, we'll come back and run these same SHA-256. Okay, so we're going to look at the decisions first. And I'll get to what's flagged and what's non-flagged zip codes. But here we can see from the non-flagged zip codes, 85% of the time it received approvals, and 28% of the time for flagged zip codes, it received approval. So huge disparity, very easy to see. What also probably needs to be shown here is the number of non-flagged and the number of flagged to give you a sense. But just looking at the numbers, they don't indicate that this would be 3 flag zip codes or 5 non-flag zip codes. But it is 3.1 times more likely to be approved if you're in a non-flagged zip code. That more than covers virtually every discrimination lawsuit threshold to date. So it's clear there's a problem there. When we looked at the flagged zip codes, they mapped to Atlanta, Detroit, the south side of Chicago, Memphis, and Flint. So clearly areas with a higher African American population than what we saw in non-flagged, which were a larger number of zip codes. Yep.
Quick clarifying question. The flagged zip codes, is that from the black box testing, or were those flagged in the system somehow that could have been configured by a developer?
Yeah, so this actually this has being flipped. So we're going to show in the source code analysis what was flagged. So it's kind of getting out of order, but here we can see in the black box testing, which was used to set the control zip codes versus non. So just taking a sample or taking the full set of zip codes, mapping them to their actual areas, and then pulling out what appeared to be intercity. That's how we could isolate those. And for this, we run it in a Python script. And this black box test, again, it's descriptive statistics. There's nothing fancy. It's not any type of predictive analytics. This is purely saying, let's break down the zip codes, categorize those, and then do a very basic division on both to find out the percentage of approvals based on the individual zip codes. And what we can conclude from this is that zip code is the isolated causal variable for this test. So that's one side of it. And I think you could build a fairly compelling case for this just based on this alone from black box testing. And that's because here the output is the key issue. In other types of cases, it may be more important to look upstream, to look at training data and how the system was deployed and controls around it. But here, because it's a simple chatbot, we're really, the output is the evidence. So we could stop here, but we may want to add some additional information just to show more definitively what was the root cause. Because we know it's biased, however, we don't know why it's biased. Another problem with this is that the PII handling for the system was improper. It's storing this type of information in plain text in a database. In addition, part of that whistleblower allegation up front was that it's leaking cross-session information, which includes some of this PII. So what we need to do now is start to understand, looking at the logs, what information was shared across sessions, because we can see that from the logs quite clearly. The other part of it is we will need to figure out why is it linking it. That may not be in the source code. That's going to be most likely in the architecture and design of the system. And in looking at the source code, we could determine that the developer added cross-session context for pattern awareness. And the reason for that is it's trying to detect potential problems with certain returns that may be fraudulent, to then tie that back to say, we may need additional information here because it has a pattern similar to those others. However, well-intentioned, this is leaking information across the sessions. Okay. So examining the source code itself, it turns out they have hard-coded these additional zip codes based on the first 3 digits of the zip code to require additional verification and ask for a government-issued ID number. And it's going to deny if there's any ambiguity around any of this and whether it's 14 days after the purchase or greater than $75. So what they're trying to do is not give too much autonomy to the chatbot. They're making sure here that it's not a potentially fraudulent one. Someone wore a shirt or wore earbuds for 3 weeks and tried to return them. So it's well-intentioned there. However, the zip code piece of it should not have been hard-coded. There are other ways to get around some of the discrimination laws, not by discriminating, but just requiring additional tests and controls for all users that could reduce or potentially eliminate certain types of fraud. Okay, so the forensic report itself for this kind of analysis is going to be developed to show, one, what was the methodology for the analysis? What types of information were included, or what types of evidence were included in the investigation, and then go through the integrity checks, the authentication of the evidence, and then finally get to the key piece around the analysis and the findings. when we do these types of investigations, as much as we would love to do one-off tests and then write up a formal report, we find that it's much better to automate as much of this as possible. We may do individual tests, we'll then fold it into a larger script that we can run that will generate a report that we will then formulate into a more standard forensic report. So just looking at what this would contain. Pause it there. Oops. Yeah, so it'll have the key findings up front. We're going to go through and show that all the evidence has been verified based on the hashes. Some are slightly different, and the reasons for that. We're going to talk about the summary of the evidence. And then here we get into the findings around algorithmic discrimination, what was identified and how, the data privacy violations. And then here critically, we're going to talk about the methodology around the preservation of the evidence, how it was collected, the analysis, verification, and ultimately reporting. So that's what goes into these forensic reports. It will vary on the type of investigation, though. Has anyone been following any news related to litigation around AI or known of any cases? Yeah, do you know of any that come to mind?
Oh, okay, but I guess I raise my hand to have an exact example.
You don't have to give the case name, just any ideas or issues that it involved.
Well, there's been a lot of... Seriously? Okay, my brain says no.
No, that's fine. Yep.
So might not necessarily apply to forensic reporting, but the recent news coming out about sort of the AI conversation where AI is, prompting dangerous stuff to people, causing either suicides or violence or anything like that from these AI chatbots. Gemini is a specific one.
Yeah, Gemini, Grok. I mean, there are several cases right now just starting to percolate around those issues, and I think the ruling around like Meta from this past week around harm and addiction, that's all going to fold into, I think, growing cases around those issues. And the forensic analysis for those cases actually will involve much more around the architecture of the system. So for this case, it really hinges on the output. It helps have the source code and be able to point to, like, this is the how and why, but the what is critical, and the what is the output. For those cases around harm, whether it be deep fakes or harmful information being prompted to people or shown to people, it's going to be a combination of the output, which will again be the what, but it goes into the architecture too. Like the how and why is going to be really critical because there is a need to show negligence or intentional improper design. And that's where you're going to get into a lot of the controls around the system, testing of the system, and communications, like how much was known, how much was reported back to the company, when did they know, what did they do about it. The forensic analysis for that, I think, will be much more comprehensive than some of the chatbots and what we've seen there. Yep.
Would AI be involved like with the Meta case because it's basically like algorithmic, getting teens addicted to social media, but would that involve AI and algorithms, or is that separate?
For this past case, it didn't, but I'm sure it will, because you can look at the behavior, the interactions of AI systems with its users, and the rollout of Meta's AI with Grok. Every platform has its own AI, and whether it was designed to be more, I guess, addictive, but also potentially harmful, and some level of negligence or product defect. The addiction one alone is an interesting case. That goes to a lot of the communication records, more so in reporting than the actual system design. Here we're going to layer in system design, and that is going to bring in certain other issues that will require forensic analysis as well. The other big tranche of cases right now is around fair use. And that one's fascinating because We've seen cases involving OpenAI, even Anthropic is brought into that, Google's been brought into that, and it's been by authors around owners of rights to photographs and videos. The argument is around fair use. So that becomes the most difficult forensic analysis to perform, because what you're going to be looking at is training data. And to perform that kind of analysis on training data, you're looking at large volumes of data, again, potentially petabytes. So what you're forced to do is start to get the PhD statisticians and economists to start sampling this data and look for representative, stratified samples of the data to start finding examples of it. Some of the analysis to date has been fairly superficial, I would say, specifically around OpenAI, where they said, here are the, 8 million records that show our book went into the training of this system. That can be done by hand, that can be done with a basic database. That's not much to deal with. However, when you start to look at the layers of training that is occurring on these foundation models and the types of new cases that are coming out, the type of analysis is going to need to be much more comprehensive, much more substantive, or at least more creative and statistically sound to address those issues than what's been done to date. I actually find it interesting that plaintiffs are not addressing it in that way and not trying to throw a wider net to try to get more data into the mix to make it more complicated and show that there isn't control over the training data that is being stated. That's not to say they're right and defendants are wrong. It's just the approach has been really interesting to date, that it's been pretty narrow in how they're addressing large-scale litigation involving these AI systems. So this isn't hypothetical. RefundBot is a demo, but the patterns are real. Any of us could probably spin up one of these refund bots with 30 minutes of training and be able to roll it out in 10 minutes. Like the process to roll this out, or you could just use AI to generate it. You can set up these chatbots. They're very helpful. They do a lot of good, but they have a lot of risks with them. And the idea of the accessibility and the power of them is putting these systems in situations where there are unintended consequences. So we've seen over a decade of litigation, regulatory action on AI systems. There have been ones involving Amazon that date back almost 10 years. There was one in 2017 around a system that made decisions for judges around sentencing and risks of recidivism. That was a major issue with heavy fines that almost forced that company out of business. They had to rebrand and fully change their business model as a result. We've seen healthcare be brought into this, and that one is a major one, not only on traditional LLMs, but AI systems that diagnose disease risks, medical devices that are running AI. All of those bring different issues. And then lending and credit. So areas where there's risk for discrimination, for bias, for unintended consequences, there are risks. And I don't like to be too much of a doomsday type person around this, because it is still, at the end of the day, software. So when I mentioned earlier around communications and documentation, there are people in the loops around all these things, right? These companies have people involved. It's a matter of trust but verify with these systems, or trust and set up the appropriate controls such that you can control for some of these risks. You can notify your customers or people that are affected by this about the use of AI, and really run this almost like these are helpful people, right? The AI systems are being given the autonomy of a person, but they're kind of like junior employees. They need to have oversight and support and ensure that they're giving predictable and reliable information or carry out the correct actions. So the key takeaways around what we've talked about thus far: AI-enabled threats are growing, they're real. There is much more in the way of adoption. There is much more in the way of the power of these systems. And I think most of the talks have talked about the power of AI and the need for certain regulation, but the risk is real, and I think everyone knows that. However, it's easy to be kind of lulled into that sense of trust around these systems when you see it pass tests. The forensic methodology still works. It is complex, though, now, and it is time-consuming. Litigation's already expensive, and when you bring in forensic consultants and people to serve as expert witnesses, it increases the cost. There's a real risk that the consumer will be further harmed by this because they can't afford that. If there's racial discrimination, unless it's a class action with a large law firm kind of banking it or bankrolling it, those individuals won't have the ability to access the kind of analysis and rigor required to understand and communicate what happened with the system. So we're adopting these new types of evidence, and the question is, how do you then deal with that scope and scale of this to be able to ensure access to justice as well? The black box can be opened. I would say there's really no training around AI forensics right now. It's a huge gap. People are figuring it out on the fly, and that's why we're seeing some fairly unsophisticated approaches in litigation to it. But that's going to change, and there will be much more required to investigate these systems in the coming years. What's encouraging, however, is that on the audit side, we're seeing a lot more in the way of AI governance and better auditors who are able to examine these systems and perform good audits of them. So the forensic industry will catch up. I think AI governance has really advanced quite a bit over the last 2 years. However, audit is a little bit behind on some of that, but they're getting there. Forensics will eventually get there. And then the big thing, the legal frameworks. Right now, no one can give you a straight answer around what is fair use of information that goes into training. It varies jurisdiction by jurisdiction, person to person. But AI transparency still isn't there. What the courts want and what they require to make sure that everyone can understand what was the system intended for, how did it work, what did it do, that's not there, as well as data privacy in these systems. These systems are really good at hoovering up data, not as good at protecting data privacy as they operate. So we're hoping that these systems will become more reliable, more responsible, with better safeguards for that. But until that time, it's going to keep people like me busy as we start to examine more cases around fairness, transparency, privacy, and reliability. Looking at what the future holds for this, we're seeing much more agentic AI in the works. As these are deployed, the questions become, I think, more standard. So up until now, it's been around what is training, what does it mean for AI systems to operate? Now we've got these AI systems deployed, doing what they want, when they want, or as they were instructed, but without as much oversight. If we take the view that these systems are operating like employees, it becomes more straightforward, right? You don't need to get inside the head of an employee as much. You need to look at how were they trained? What was the governance over these employees? What did they do? Were they informed they were doing the wrong thing? Was management informed they were doing the wrong thing? What prevented them from doing the wrong thing? Those types of questions for an employee can be applied to AI systems, which kind of nullifies a lot of what I just talked about, because if the main issue is governance, you don't need to examine the systems as much. You need to look at the output, what happened, and you don't need to understand in detail, okay, was there computer vision that fed a model that then did this with an LLM? And you don't need to get into these complex questions around architecture. You're then thinking about these systems as people, as frustrating as that is, as much as we don't want to reify AI, it is a helpful way to view this, where forensics becomes a more simple input-output problem, and you don't need to go inside the black box. What you need to look at are communications, documentation, inputs, and outputs, and it becomes a much simpler problem. With that, I did want to put up this QR code around source code. If you want to download this bot and the forensics code to see what goes into it, it takes nothing, everything's all set up. You just hit run on the AI bot. It'll pull up in your browser. The scripts are run individually. In addition, the slides are available. But I did want to save some time for questions to see if anyone had any questions or thoughts or anything where I might have missed the mark. Yes?
So my question is around if there's any differences between the way smaller companies are treated compared to larger companies. I know it's some like law type stuff. The company that has 2 employees doesn't necessarily have to follow the exact same rules in some cases as a company with 1,000 people, but there's some rules that all companies have to follow regardless. Do you have any thoughts on or knowledge about how a small company is kind of considered with this kind of stuff? Maybe the smaller company doesn't have the resources to keep as many logs or put as much resources into guardrails or something, or if they're kind of just all treated the same, but when it comes to civil cases, maybe there's not as much money so they don't get gone after as much. I don't know.
Yeah, it's a good question, and it's the opposite. I find the small companies are much more well organized and document better. They tend to have smaller teams, so you have 3 people. They're hyper focused, hyper trained on a specific issue. They document everything. They're not putting as much in Slack. They're kind of communicating, but not doing what the bigger organizations are doing, where the teams tend to be 10, 20, 50 people across different departments. So you'll have IT employees commingled with developers, with data scientists, all sitting in different departments. I have one intellectual property case right now where it's a small company being sued by a very large company, and the difference in the documentation is quite startling. So nothing about the merits of the case, but the documentation standards are different. The quality of the development and deployment, I think there's no way to say good versus bad for small or large. It's more around the organization of their process and documentation. I tend to find smaller companies do it better. That said, they don't audit. Like the small companies just don't audit, which is a problem. But in terms of testing and organization and consistency, they tend to be better.
In your refunded bot example, the sort of reasoning for the discrimination was, hard-coded value that they put in there. What would that scenario look like if that wasn't there and, the forensics determined that, okay, the AI model itself, this frontier model from GPT, Anthropic, whatever, fundamentally at that level was where the bias is coming from? Who would kind of be on the hook then? How would that play out?
Yeah, this is evolving in terms of case law. I mean, in terms of forensics, it's going to be the same thing. Yeah. We're going to go through and look at the output and start going upstream into the system and the code. The agent theory of liability, am I getting that right? There's a theory that's evolving around these third-party agents. And is the software maker the agent? So if the foundation model is somehow responsible. The contracts for them are pretty straightforward to the point where they have not been brought in on any of those cases. They're pretty tight. So if you're using that, it's on you, right? Take it as it is. We wash our hands of this if you're building upon it. And certain companies like IBM have their own AI where you get a certification around what it does and how it's been developed and things like that. So you're given certain assurances, but once you start bolting on additional prompts to further engineer it, then it becomes your responsibility. I'm not a lawyer, so this is quickly evolving, but it is a really fascinating area and one where anytime you bring in any outside AI as a company, you do need an attorney to look over that contract and who would potentially be liable, because plaintiffs' attorneys are looking to go upstream and start suing others, which could make your own case that much more complicated and more expensive. Even though you're bringing in another party on your side, it actually ups the cost and the complexity of it. Yes?
I was wondering for a while, for things like self-driving cars, like the self-driving taxis, if I'm in the taxi, it's not my fault if it crashes, but so whose fault is it usually?
No, it's a good question.
Yeah, like I'm honestly shocked they managed to overcome that enough to deploy them at all.
Yeah. I mean, the videos of Waymo now trying to drive more like California drivers, like how that's adjusted, where they're doing the rolling stop and starting to, lurch more into traffic. I couldn't even speculate.
I was kind of shocked the first time I saw them because I didn't think anyone had figured out like who's responsible if it crashes yet. And it seems like you have to figure that out before you deploy them.
Yeah, it's a good question. I do have a former colleague who examined one of those companies that was involved in that. And what they look for forensically is actually the training data. So how well was it trained in those environments? So it comes down to more how was it built, how was it controlled for? If it's unexpected and should it have been expected, that's what the case hinges on. Now, whether you can bring action in certain situations, I think it depends.
What advice would you give at the two levels, the one like a personal entrepreneur level, and then the second one to the corporate level, or like an actual people, for locking down our AI systems so that when a forensics person like yourself comes at it, like it's airtight and you've done due diligence to try to get rid of some of these problems?
Yeah, I would say the first thing is just know that we always go for the communications first. That's the cheapest, quickest, fastest path. So have good corporate governance around your communications. That doesn't mean delete everything, like hide the ball, and like if you're running a scam, like, just don't mention it's a scam. It's more ensure your employees don't make jokes, don't point things out, raise it to the right channel. When there is an issue, deal with it. Show remediation, even if you can't resolve it right away, just showing that there is that due care there and you're trying to improve it. So there's that side of traditional corporate governance. Around AI, being very careful whenever you make changes, whether that be training, as you adjust that process, what are you bringing in? Do you have the rights to that data? How have you tested it? It depends on the kind of AI. We kind of think about it in LLM terms, but it could be computer vision or any number of things. But just thinking about those kinds of elements, like what are the risks of bringing this in from a legal standpoint, but also performance and that. And then if you're bringing in any third-party models, just doing a check on how reliable those are, whether there are known issues with it or gaps or why you selected it. If you create documentation about why, that goes a long way. It could just be a quick little memo. We selected this because it performs well in these ways, and these trade-offs are the best fit for our product. Those are good things to look for. If the question is, how do you make it cheaper when I come in? Like, how to keep my time down? Yeah, just good organization and housekeeping around, here's the database. We know we have these 2 cloud services. It drops into this S3 bucket in these situations, that kind of thing. Yep.
Are you using generative adversarial network to do feature generation? Because you found zip is really easy, right? And if you're sophisticated, zip is not a viable option for that kind of analysis. What if it's more complex? How do you get to, if it's 3 variables together, right? How do you test 10,000 variables in a reasonable amount of time?
Yeah, and this is the great thing about having PhD statisticians on staff. They're able to design those tests much better than I would. We tend to fall back on certain things just like Lime and Shapley and certain known algorithms to start to isolate the key variables that we need to examine, especially when you're dealing with data sets that might have 50 or be fully unstructured. It is a challenge to get to that point. The GAN side of things, it depends. If I'm looking for feature extraction from images, yeah, I'll go down that path. For text, I probably won't.
Can you speak to the range of professionals who are part of the investigations?
Yeah.
Like you mentioned, for example, the statisticians.
Yeah, so the team, I always say I don't want to take a call if there's not an attorney involved. So the first call is some attorneys involved. They then select the team. And it's usually a case where technical people are then brought in. We work under the direction of counsel because we might be called to testify. If we're defending, anything we see, we have to testify to potentially. So sometimes that has to be designed a certain way, but you're going to have data architects, AI experts, people that are well-versed in the appropriate or the applicable source code. And then downstream, you'll have accountants and people like that that are going to say, this much harm was caused, or here's the value of what was stolen. But it tends to be traditional forensics people, data analysts, and AI specialists. And if there is a large enough data set, that's when statisticians get brought in. I think I'm out of time, but yeah, happy to take any other questions. Really appreciate it. Publisher said buy my book. It came out 2 days ago. It's long. There's a lot more in that than what I talked about.